Welcome to Cosmic Compass, where we journey together through the wonders of space astronomy and the mysteries of the universe. Each episode we explore strange worlds, cosmic phenomena, and the science that connects us to the stars. Let's set our course and begin today's adventure. Imagine a world where the ground never rests. Volcanoes erupt, relentlessly spewing plumes hundreds of kilometers into the sky. Rivers of molten rock carve through colourful plains of sulfur, while auroras shimmer across the horizon, painting the heavens with surreal shades of red, green and blue. This is not a vision of some mythological underworld. It is very real. Welcome to Io, one of Jupiter's moons, and arguably the most extreme and restless place in our solar system. Io is often described as a world of fire and brimstone, and with good reason. Unlike the frozen surfaces of Europa or Ganymede, Io is alive with ceaseless volcanic activity. In fact, it remains the only body in the solar system beyond Earth where active erupting volcanoes have been directly observed. Today, we are going to explore everything that makes Io unique: its position among Jupiter's moons, its internal structure, the violent forces that shape its surface, the long journey of spacecraft that revealed its secrets, and the breathtaking way it interacts with Jupiter's immense magnetic field. So let's take a journey together and unravel the story of this hellish yet mesmerizing moon. By the end, you may find yourself questioning if such a fiery world can exist so close to a giant planet. What other strange places might be out there in the vast cosmos waiting to be discovered? Jupiter is home to an astonishing family of moons, 79, that we know of so far. Most of these are small, irregular satellites orbiting far away, but four stand apart: the Galilean moons discovered by Galileo in 1610. From the innermost to the outermost, these are Io, Europa, Ganymede, and Callisto. Together, they form one of the most fascinating miniature planetary systems in existence. Io is the closest of these giants to Jupiter, orbiting just 350,000 kilometers above the cloud tops, closer than our moon is to Earth. From Io's surface, Jupiter would dominate the sky, appearing nearly 40 times larger than our moon does to us. Imagine standing there, looking up at a planet so massive it fills the heavens. Unlike our moon, which takes nearly a month to circle Earth, Io completes an orbit around Jupiter in just 42.5 hours. It races around its parent planet, locked in a gravitational dance, not just with Jupiter, but also with its neighbouring moons. Io is in what scientists call an orbital resonance. It completes 2 orbits for every orbit of Europa, and 4 for every orbit of Ganymede. This resonance prevents Io's orbit from becoming perfectly circular. Instead, it is slightly stretched or eccentric, and this tiny eccentricity has enormous consequences. Jupiter's gravity, combined with the tugging of Europa and Ganymede, constantly flexes Io like a ball of putty. The friction generated deep inside translates into immense heat, what scientists call tidal heating. On Earth, tides raised by our moon shifts our oceans by a couple of meters at most, but on Io, these tidal bulges in the solid surface can rise and fall by up to 100 meters. That's the height of a 30-story building, caused solely by gravitational forces. This relentless kneading pumps staggering amounts of energy into Io's interior, driving the intense volcanic activity that defines the moon today. Io is not a small world. With a diameter of about 3,600 kilometers, it is slightly larger than our moon and ranks as the 3rd largest of Jupiter's Galilean satellites. Its size gives it a gravity comparable to the moon's, meaning you could hop around almost as easily as on our own satellite. What makes Io unique, however, is not its size, but its composition. Io has the highest density of any moon in the solar system, an indication of a rocky metallic interior rather than one dominated by ice. While many moons orbiting the giant planets are rich in water ice, Io is virtually bone dry. In fact, it has the least water of any known celestial body. At its heart lies a core of iron or iron sulfide surrounded by a mantle of partially molten silicate rock. The mantle extends upward to a crust where volcanic activity breaks through. Unlike Earth's core, Io's is not thought to be convecting, which explains why Io lacks its own magnetic field. This interior structure makes Io behave more like a small terrestrial planet than an icy moon. It is often described as a mini-Earth, but one that has been thrown into a furnace. The absence of water means the chemistry of its surface is dominated by sulfur and sulfur dioxide. These compounds are constantly reshaped by eruptions painting Io in vivid yellows, reds and whites. Locked tidally to Jupiter, Io always shows the same face to its parent planet, just as our moon always shows the same face to Earth. This gravitational lock, combined with the tidal heating we explored earlier, ensures that Io's surface is never stable. Beneath its thin crust, molten material churns, waiting to burst forth in colossal volcanic events. In short, Io is both familiar and alien, a rocky world, not unlike Earth, yet sculpted into something utterly different by its relentless proximity to Jupiter. For centuries after Galileo first spotted Io, it was just a point of light in telescopes, one among many moons orbiting the giant planet. Its true nature remained hidden until the dawn of the space age. The first spacecraft to get close was Pioneer 10 in 1973, followed by Pioneer 11 a year later. These probes gave us the first blurry glimpses of Io, hinting at a rocky surface rather than the icy one scientists had expected. But the harsh radiation near Jupiter severely disrupted Pioneer 10's instruments, preventing close-up photography of Io. It was a reminder that studying this world would not be easy. The real breakthrough came in 1979 when Voyager 1 swept past Jupiter at just 20,000 kilometres from Io. What it revealed stunned the scientific community. Instead of a cratered, ancient surface like our moon Voyager showed a colourful landscape completely reshaped by active geology. Towering mountains, immense lava flows, and most shocking of all, giant volcanic plumes rising hundreds of kilometres into space. For the first time, humanity had witnessed active volcanism on another world. Just 4 months later, Voyager 2 passed by, confirming that many of the same volcanoes were still erupting. This proved Io wasn't just geologically active once it was active all the time. In 1995, the Galileo spacecraft arrived in orbit around Jupiter, and for nearly a decade it returned detailed images of Io's surface. Galileo captured lava lakes, ongoing eruptions, and even the cycling activity of Loki, the largest volcanic depression in the solar system. Though mechanical failures limited the spacecraft's abilities, it still provided our most detailed record of Io to date. Then, in 2007, the New Horizons mission to Pluto used Jupiter for a gravity assist. During its brief flyby, it turned its instruments toward Io. By sheer luck, the Tvashtar volcano was erupting at that moment. The spacecraft caught breathtaking images of plumes stretching hundreds of kilometres high, glowing against the blackness of space. Through these missions, Io transformed from a point of light into a world of fire, a reminder that the solar system still holds surprises. And with each encounter we came to realise this is not just a moon, but a volcanic giant, unlike anything else we know. If there is one feature that defines Io, it is its volcanoes. Nowhere else in the solar system apart from Earth do we see such explosive volcanic activity. Yet Io surpasses Earth in both scale and intensity. Its surface is dotted with hundreds of active volcanoes. Some are small vents, while others are calderas the size of countries. Pele, one of the most famous, produces vast plumes of sulfur dioxide gas staining the surface with striking red deposits that stretch for hundreds of kilometres. Loki, by contrast, is a massive lava lake about 200 kilometres across. On average, Loki alone accounts for a quarter of Io's total heat output, and when its crust collapses it can glow with 10 times its usual power. Tvashtar, perhaps the most dramatic of all, erupted spectacularly during New Horizons' flyby, shooting molten material into space in a display so intense it appeared as a white-hot glare to the spacecraft's cameras. What makes these eruptions different from those on Earth is not just their size, but their frequency. Io is never still. At any given time, multiple volcanoes are active, resurfacing the moon so quickly that impact craters are virtually absent. This lack of craters is in itself evidence of constant renewal. Io also hosts enormous mountains, some higher than Mount Everest, rising as solitary peaks rather than ranges. These mountains, formed by tectonic stresses in the crust, often lie near volcanic depressions, hinting at a deep connection between Io's surface fractures and its fiery interior. The colours of Io are unlike any place else. Vast yellow plains of sulfur, brilliant white patches of sulfur dioxide frost, and deep reds from volcanic deposits combine to create a landscape that seems almost surreal. If you could stand there, the sky would be dominated by Jupiter, while the ground beneath your feet trembled with the rumble of distant eruptions. It would be both terrifying and breathtaking. Io is in every sense a world sculpted by fire. Its restless surface tells a story of immense internal energy, driven by forces that we are only beginning to understand. Io's uniqueness does not end at its surface. Its relationship with Jupiter's immense magnetic field adds another layer of wonder. As volcanoes hurl sulfur and oxygen into space, Io creates a thin but active atmosphere. Much of this material escapes into surrounding space, forming a vast cloud of neutral gas that trails Io in its orbit. But once ionized, these particles become trapped in Jupiter's magnetosphere, forming a massive plasma torus, a donut-shaped ring of charged particles encircling the planet. This plasma torus rotates far faster than Io itself, at speeds of around 70 kilometers per second compared to Io's orbital velocity of just 17. As Io plows through this environment, it becomes a generator of electric currents, feeding roughly 1 ton of material every second into Jupiter's magnetic field. The results are spectacular. Magnetic field lines linking Io to Jupiter create what scientists call the Io flux tube, a channel of electrical energy stretching between the moon and the planet. Where this energy strikes Jupiter's upper atmosphere, it triggers brilliant auroras, glowing spots that mark Io's presence like a cosmic fingerprint. Io itself also experiences auroras. Unlike Earth, where auroras are confined to the poles, Ios appear across its surface. Different colours reveal different elements: green for sodium, red for oxygen, blue for sulfur. Together, they transform this volcanic moon into a shimmering jewel orbiting within Jupiter's magnetic grip. If we could see Jupiter's magnetosphere with the naked eye, it would appear as large as the full moon in our sky. Io, sitting within this magnetic giant, is constantly bombarded, stripped, and reshaped by forces invisible to us, but astonishingly powerful. This interplay of geology and magnetism makes Io a world of extremes, not only a furnace of molten rock, but also a participant in a vast electromagnetic dance with its parent planet. So what have we learned about Io? It is the most volcanically active body in the solar system, its surface reshaped constantly by colossal eruptions. It is a moon with the density of a planet, composed of rock and metal rather than ice, and dried of nearly all water. Its mountains rise higher than Earth's tallest peaks, while its skies glow with auroras created by its intimate link with Jupiter's magnetic field. Io is not just a moon, it is a reminder that the solar system is still alive, with dynamism and extremes. While Europa may inspire dreams of hidden oceans and possible life, Io tells a different story, one of fire destruction and raw geological power. As we continue to explore the outer worlds, Io challenges us to reconsider what a moon can be. It shows us that beauty in the cosmos is not only found in serene ice fields or glittering rings, but also in the furious heart of a volcanic world. We hope this journey has sparked your imagination, and perhaps you're asking yourself, if Io can be so extraordinary, what else might await us among the countless moons and planets beyond? Let's keep exploring together, one world at a time. Thank you for joining us on this journey through the cosmos. If you enjoyed exploring with us, don't forget to like, share and subscribe for more stories from across the universe. Until next time, keep your eyes on the skies and let's keep navigating the stars together.